Welcome back. If you're watching this video, then I'm assuming you've watched a previous video that I made, the first video on just the basics about Lewis structures. If you haven't watched that video, you're going to want to stop watching this one, go back to that one, and get the basics on Lewis structures. As you see here on the screen, I already have some information, or maybe I won't even show you this information, I'll just show it to you later. But I'm picking up where we left off on the previous lesson. So once again, go back and watch the first video on Lewis structures before you watch this one, because I'm going to run with this information just a little bit faster than I did before. And let's get started. So in the previous lesson, we talked about Lewis structures, what they were, and that we're just basically trying to get this three-dimensional aspect, this concept, this geometry behind molecules, because we live in this three-dimensional world. So I want to expand that out to, I don't want to say things that are more complicated, but we're going to look at some structures that are a little more complex than what we did in the very first lesson video. So let's go with, this time, I want to do something with, say, a polyatomic ion. So let's go with like hydroxide. So we know hydroxide, I already got that there. We already know hydroxide is an OH negative. So polyatomic, more than one, remember, and there's a negative charge. So remember the first rule is the sum of the valence of all electrons. So we know oxygen and hydrogen. So there's one oxygen here, one hydrogen here, times the oxygen, we know it has 6 valence electrons, and in the hydrogen, we know it has 1 valence electron. So that would be 6 times 1 is 6 electrons, 1 times 1 obviously is 1. So that gives us, this new Apple Pencil, I always double tap that and I switch to the eraser unconsciously. I may turn that feature off. It's nice, but I tend to erase a lot. So there's 7. Well, let's think about this. When we were talking about this before, when we bond all atoms, when we bond them, there's a sharing of electrons. So that's a pair of electrons. So a bond is literally 2 electrons, 1 pair. That's an even number, not an odd number. Here we have 7 electrons. Something's not right. Then we're going to satisfy the octet rule, the 8, by adding lone pairs, right? Well, once again, that's 2 electrons when we're talking about 1 pair. So we look at this 7 and we realize something's not right. We have that negative charge right there. That negative charge means that this group of atoms, this oxygen and this hydrogen that are bonded together covalently, had to have picked up another electron. So we know that we're going to have to add 1 electron here, and that gives us 8. Now we have an even number. Now we can build this structure, all right? So let's go ahead and do that. So we've summed up the valence electrons. Check. Let me put that over here. Oops, see, I did it again. Check. All right, so now we've got to bond all atoms. Let's go ahead and put this together. We've got oxygen, and then we've got bonded to a hydrogen, right? And then check. Rule 2 is done. We're actually almost done with this molecule. Rule 3, we're going to satisfy the octet rule by adding lone pairs. Remember, hydrogen follows the duet rule. So once it bonds, then the pair of electrons that's there between the 2 atoms satisfies hydrogen's bonding pattern. So now that means we're just going to add a pair here. So that's 2, 4, 6, and then that pair there's 8 around that oxygen. So we have now satisfied the octet rule. So now we go back and we look and we make sure that all 3 rules are satisfied, particularly that once we finish this 3rd rule, once we add lone pairs everywhere where we need to satisfy the octet rule, what we want to make sure is that we have not violated rule 1. We haven't broken rule 1. And so what oftentimes, and as you saw in the previous video, if we add lone pairs, we can usually get more electrons than what we already determined that we needed. And so usually that means you have to shift bonds and lone pairs and recount, right? So right here, let's take a look. We need a total of 8. So we've got 2, 4, 6, 8. We've got all 8 electrons. Rule 1 is still good. Rule 2 is still good. Rule 3 is still good to go. All this, this is fine. We've got a structure that now works. Again, so if we look at this, we could say we have 2, 4, 6 electrons in lone pairs. We have 2 electrons in bonding pairs. Or we could say we have a total of 3 lone pairs or 1 bonding pair. So depending on the way the question is asked, depends on how we answer the question, obviously. So now there's one more thing we have to do. When you have an ion, if you remember your earlier studies in chemistry, particularly when we did like ionic bonding, we learned that when you put brackets around something in chemistry, it's our way of sort of denoting, sort of identifying things where there's a concentration, all right? And so right now, we have a concentration of more electrons that have occurred. So when we have our ions, we always tend to show a bracket to show where the charge is occurring. So right now, what we do is we realize, okay, there is an extra electron charge on this. We don't call it a molecule, we call it a polyatomic ion because it's a molecule with a charge. And so there's our negative charge. All right? I mean, you may see it sometimes. Usually we tend to write things on the right side, but this is one of those instances where you'll typically see it written here because we know the negative charge is being carried on the oxygen. And that'll be a lesson in future videos when we talk about a concept called formal charge. So there's another lesson video for that. You can watch that when at your leisure. So there we go. There is hydroxide. Let's do one more. Let's do one more real quick. So let me go ahead and get rid of this. All right. Let me make that larger. Let me get rid of this. Let's get our space back here. Get rid of these check marks, just so we have our little checklist. All right. Let's look at cyanide. That's cyanide. All right. So cyanide is Cn minus. All right. Cn minus. All right. One moment. All right. So we've got carbon and nitrogen. Let's go ahead and sum up all the electrons. So here is carbon and nitrogen. And let's see. I'm gonna put my work down here. Carbon and nitrogen. All right. So we've got 1 carbon, 1 nitrogen. Carbon we know has 4 valence electrons, and nitrogen has 5 valence electrons. So you should be able to see here. Wow, that's a really horrible 5. That is 9 valence electrons. That, you should immediately be able to see. Wait a minute. If we have an ion, we're going to have to do something where we're going to have to something with some electrons, right? So the negative charge again on this polyatomic ion means that it has taken in 1 more. So that's a total of 10 electrons that we need on this particular polyatomic ion. So rule 1 is done. Rule 2, bond everything together. So there's carbon bonded to nitrogen. So now rule 2 is done. Satisfy the octet rule. So we're going to go 2, 4, 6, and then right there is 8 around that carbon, right? And so this 2, 4, 6, 8 around the nitrogen. And so we've satisfied the octet rule. If we were to, so if we look around carbon, remember 2, 4, 6, 8, right? Around the nitrogen, 2, 4, 4, 6, 8, because there's that covalent sharing, right? So we've satisfied the octet rule. If we were to now go back to rule 1, 2, 4, 6, 8, 10, 12, 14, we need 10. 14, so we have 4 more than what we need. So we need to pair, we need 2 different types of pairing systems, right? It's a pair. So, just like we learned in our previous video, that we can move electrons, and if we remove a pair of electrons here, and here, that might change things up just a bit, right? That's 2 pairs of electrons. So now let's think about this. All right. Now that those are there, there's a bonding pair, and there's a bonding pair. All right, so now let's recount. We've got 2, 4, 6, 8, 10, 12, 14. There's still too many. But remember, we've moved electrons, so at this point now, what we have to do is ask ourselves, how do we get 8 around each atom? Well, 2, 4, 6, this being shared with carbon. So if we were to erase one of these, we now have 2, 4, 6, 8 around the carbon, right? So now, let me erase that. Well, you should be able to see that if I erase this right here, I've got 2, 4, 6, 8 around the nitrogen. Now let's recount. 2, 4, 6, 8, 10. I meant to highlight the whole thing for you. And that's the 10 that we need. We got this, we're good. So there's our structure, right? There's our structure. Once again, it is an ion, so you put it in brackets. And this structure has a negative charge, since this is a polyatomic ion. So there's our Lewis structure for this particular type of molecule, our polyatomic ion. So let's build this thing. So we've got carbon, right? Remember, carbon's the black piece, and then we've got nitrogen. So this time, actually, I need a blue. So we've got carbon, and according to this, there are 3 bonds. So that's 1, 2, and then 3. So I'm going to use the smaller kit that we learned in the previous video. Why? And the reason why is because it helps us see regions of space, physically see the regions of space that exist. And so we've got right here, there's our carbon, right? There's our carbon atom. There's our nitrogen atom. We have 1, 2, and then the third that I'm holding, bond. And then if you look on the Lewis structure here, on the screen, the carbon right there, it has, we said this post represents a region of space where there's a lone pair of electrons, a non-bonding pair. So our lone pair on carbon is right here on the side, and on nitrogen, the way we have it drawn here, it's also right there on the side. And so you can see that everything is in this nice straight line. And that's going to be another lesson, a future lesson. Right now, we're not worried about that. Right now, we're worried about just building these structures correctly. We'll give names to all these different shapes in another lesson, and that'll be another video. So our Lewis structure here and this physical, they match each other, all right? They do match each other. Now, you'll notice that I had to bend the bonds, right? And so that means you should see that a triple bond is actually shorter than a single bond. So when we draw this, we really want to go carbon, and we want to show those triple bonds, much shorter, because that's what really happens. Put our negative charge back, and we're good to go. And so I'm going to build this carbon and nitrogen using our larger molecule kit. All right, you'll remember, and I highly recommend that you actually go out and purchase yourself one of these kits. I mean, there's all types that you can get. This particular brand, and this is not a sponsored video or anything, but the Old Nobby, we have found that they work really well. They're very affordable, and they do basically the same thing that your more expensive ones do. They have all the, it's just, they're really, really nice. Really, really nice. I really like them. And so we've got over here it's carbon. It's a new kit, so I have to put some force into it. So we've got our carbon, triple bonded. There's 1, 2, 3 bonds with the nitrogen. And what you have to use is your imagination to realize that there's a lone pair here on this side, and there's a lone pair here on this side. Okay. And now typically, carbon likes to have as many bonds as possible. It wants to form 4 bonds. In this instance, it can't form 4 bonds. So in another video, we'll take a look at some of those peculiars about that. But to kind of to help you emphasize on these kits, you would notice that there's actually an extra hole here where you think, wow, something else should bond here. And something else actually could bond here. All right, it actually could. We're going to find when we get to organic chemistry that there could be another bond here and other things happen. Because right now there's just a lone pair there. All right, so I'm going to erase this because what I want to do is show you something. We already know we need 10 electrons. That's already done, right? So let's remember that carbon, right? Let's remember carbon has 1, 2, 3, 4 valence electrons already. And nitrogen has 1, 2, 3, 4, 5. So nitrogen already had a lone pair, okay? So if we think about it, those paired up, and those paired up right there. So what that means is, and I'm going to erase this old one we don't need anymore, is carbon paired up with nitrogen 3 times. And then this lone pair here basically shifted and pushed to the side. Because remember, those electrons are repelling each other. So as everything got closer, everything's being pushed and repelled off to the side. So what happened was that lone pair moved out to there. So now we've got this lone pair right here that sort of got pushed out away to the side. As you saw me physically bending these atoms, that region of space, so to speak, is shifting over here. We can think about it that way. All right. So that means there was an electron here. Well, there can't be a lone electron. There's 9 electrons. So what happened was a free electron that's in the environment, whether it's in the body system, out in the environment, wherever it is, came over and was picked up, put into that spot, which helped stabilize it. And when it did, it became charged by 1. All right. Hope that helped. Go get yourself a kit. These things are invaluable. It's like toys. This is like chemistry toys. We do this when we're children. We play with puzzles. We play with toys and stuff like that. We learn by physically manipulating stuff. The $20 you would spend on getting this kit that I've given in the planning guide and stuff like that, it will do wonders for helping you really learn this stuff. Pretty soon you won't need this kit like this. You'll be able to see it in your mind's eye, and you'll just be able to manipulate all those little different pieces and parts. Your mind will thank you. Glad you were here. It's always good learning with you. Stay curious. I'll see you in another lesson really, really soon. Go get yourself a kit. Go buy one. $20. Well spent. Bye. I'll see you in another lesson soon.